Okay, so the finale of solving, the reason we use matrices is they're a convenient way to solve systems of equations. First, you write a matrix equation. To write a matrix equation for the system of equations, you want your equations in standard form. So your x's and your y's lined up equals to a constant. So then you can pull out the coefficients. This is called the coefficient matrix. So there's a 1 in front of an x, there's the 4 in front of the y, there's a 3 in front of the x in the second equation, and a 6 in front of the y. Okay. You pull the variables over here into x and y into a 2 by 1 matrix, because remember when you're multiplying you take a whole row by a whole column, and so the 1 would get put with the x and the 4 would get put with the y. The 3 would get put with the x, the 6 would get put with the y. Okay, and then that will equal the constants 2 and 6. Okay, so in order to do this we have to cancel off this matrix here to get x and y by itself. And then whatever way we cancel this matrix, we have to do it to this side to keep the equation balanced, like always. Whatever you do to one side, you do to the other side as well. So the way to cancel off a matrix is to find the inverse of that matrix, which we studied before. So we're going to get the inverse of this matrix that's 2 by 2. Okay, so first the determinant. We're going to, let's see, 1 times 6 is 6, 3 times 4 is 12, so 6 minus 12 is a negative 6. So we're going to have 1 over negative 6 times, switch the 6 and the 1, change the signs of the 3 and the 4, and scalar multiply here, so negative 1, 4/6, 3/6, negative over negative becomes positive, and negative 1/6. Okay, you know what, and I'm going to go back, and even though it's very exciting to say 1 here, I'm going to write 6 over negative 6, just so everything's going to have a common denominator. So that's my inverse matrix. Okay, if I multiply that on both sides of the equation, I would cancel out my matrix on the here. Something times its inverse cancels out, and it would just leave x and y. So I only have to multiply my inverse matrix times the 2 and the 6. So I'm going to bring down that 2 and that 6 right here, and I'm going to multiply my inverse times that. Alrighty, so when a 2 by 2 and a 2 by 1 multiply, I'm going to expect to get a 2 by 1. So here we go. I have to do 6 over negative 6 times 2. Now remember there's an over 1 here, so that's going to multiply 2 and 6 on the top, you'll get 12, and negative 6 and 1 on the bottom, so you'll get negative 6. Okay, remember there's a 1 here too. So when I multiply 4/6 times 6 over 1, I have 4 times 6 on the top, which is 24, over 6 on the bottom. And then I need to add those like terms. I can slide that negative up to the top there. So that's going to be a negative 12. So negative 12 plus 24, that'd be 12 over 6, which is 2. On the bottom, now I'm going to take the second row and multiply by this column here. So 3 times 2 makes 6 on the top, 6 times 1 makes 6 on the bottom, plus negative 1 times 6 on the top, and 6 times 1 on the bottom. So add my fractions right there, that's 0 over 6, otherwise known as 0. So my top answer is 2. My bottom answer is 0, And that's important because whichever one was on the top is x, and the one on the bottom is y. So we have solved the system, and we have found that x equals 2 and y equals 0. Let's try again. Okay. So, matrix equation has a 6 and a -5 and a 7 and a 15 times xy equals 21 over -13. Alrighty, I need an inverse. So I multiply to find the discriminant. So 90 and then -35. So 90 plus 35, because it's minus negative. So 125. Ew, that's a big one. All right, so then we'll have to do 1 over 125. Now remember, when we're making the inverse here, we have to switch the 15 and the 6. We have to switch that diagonal. And we change the 7 to a negative and the 5 to a positive because we trade the signs on those. Okay, so now distribute the 1 over 25. Keep the common denominator so that we'll be able to easily add the fractions together later. So that just these numbers all have 1s underneath them, so we're just putting those numbers on top. So -7 over 125 here, and 6 over 125 here. And those are some messy 5s due to the stylus, but that's okay. Okay, so we're going to multiply that by 21 times -13. Okay, don't panic. Sounds horrible, but it'll be fine. Okay, so we have to do the entire first row by the entire first column. So we have to do 15. Remember that 21 has a 1 underneath it, so we have to do 15 times 21, which is 315 over 125. And we have to do 5 times -13, so we have to do -65 over 125, which is 250 over 125, which is 2. Whew, that's the top number, so that's the x. All right, bottom number. We have to take the entire row 2 by the entire column 1. So we have to do 7 over 125 times 21 over 1. So we have to do 21 times 7, 147. Ooh, that was negative, I'm sorry. -147 over 125. And then we have to do 6 times 13, second row with second number with second number. So we have -78 over 125. Okay, so that is -225 over 125. And that's not a beautiful thing when we divide, but it's not horrible either. It's -1.8. And that's the number on the bottom, so that's our y.